Hello everyone, welcome to IB Math Solution. Today we will be studying special number sets. The first one is natural numbers. So natural numbers is denoted by this letter, but for simplicity we'll just write n. And what are the natural numbers? Natural numbers is a set of numbers starting from 0, 1, 2, 3, 4, 5 and so on till infinity. The second type is integers. Integers is denoted by this character, but for simplicity we'll write it z. And integers are from negative infinity to -3, -2, -1, 0, 1, 2, 3 and so on till positive infinity. The third kind is positive integers. So we have a set of integers, and this part over here is a set of positive integers. So this set can be represented by 1, 2, 3 and so on till positive infinity. The fourth type is rational numbers. Now, rational numbers are those numbers which can be written in the form p divided by q, where p and q both are integers. Or a rational number can also be written in the form 1 decimal 23, or it can also be written in the form 3.196 bar. Now this bar means recurring. So in this whole number can be written as 3.1966666 infinite number of times. So any number that can be written in either p divided by q form or in a decimal form that terminates. Terminate means there are certain number of digits after decimal, or in this form. Now the next kind is irrational numbers. Irrational numbers are all those numbers which are not rational. That's why it is q prime. So all the irrational numbers will be of the form 5.196281134 dot dot dot. So these numbers are non-recurring and non-terminating. Now the sixth kind is real numbers. All numbers can be written as real numbers until and unless they are imaginary numbers, not imaginary. Now what do we mean by this imaginary? Imaginary means square root of -1. Any number that is not in this form is a real number. So let's move on to exercise 2D and solve some questions. Now first question says copy and complete. So there are certain numbers, we have to tell whether they are part of this set of natural numbers, integers, rational numbers and real numbers. So natural numbers are 1, natural numbers are 0, 1, 2, 3. Integers are -3, -2, -1, 0, 1, 2, 3 and so on. Rational numbers are of the form p divided by q, or 1.23 or 1.31 bar. And real numbers are any other numbers that are not imaginary. So let's take the example of natural numbers and check each number. So 6 is a natural number. Yes, it falls under this set. Negative 3 by 8 is not a natural number. 1.8 is not a natural number. 1.8 bar is not a natural number. Negative 17 is not a natural number. Square root of 64, that will be 8. Yes, this is a natural number. Pi by 2, we all know pi is non-terminating, non-recursive. So it is irrational number. And being irrational, it cannot be an integer. And it cannot be a natural number. So pi by 2 is not a natural number. Square root of negative 3. Now we have negative sign in square root. That means it is an imaginary number. So it is not even a real number. Negative square root of 3. Now this is irrational number. This is not natural. Now going on to integers. We know negative 3 by 8 is not an integer. 1.8 is not an integer. 1.8 bar is not an integer. Negative 17, yes, this is an integer. Square root of 64, yes, this is an integer. Pi by 2 is not an integer. Negative square root of negative 3 is not an integer. Negative square root of 3 is not an integer. Now, rational numbers. So 6 can be written in the form p by q by writing 6 by 1. This is in the form p by q, that's why it is part of q. So it is part of rational number. Negative 3 by 8 can be written in the form p by q, where p and q both are integers. So negative 3 by 8 is a part of rational numbers. 1.8 is also a part of rational numbers because it is coming in this form. 1.8 bar is also a part of rational numbers. Negative 17 is a part of rational numbers because negative 17 can be written as negative 17 divided by 1. Root 64, square root of 64 is a part of rational number. Pi by 2 is irrational, so it is not a part of rational number. Square root of negative 3, it is not a rational number. Negative square root of 3. Now it is also not a part of rational number because root 3 is irrational. We know all numbers are real numbers except for the imaginary ones. So among all these numbers, there is only one square root of negative 3 that is imaginary. So this will not be a real number. Apart from it, all numbers will be real numbers. Let's move on to the next question. Determine whether each statement is true or false. So z plus is a set of positive integers, but negative 7 is not a positive integer. So this will be false. 2 by 3 is not a part of is not an element of integers. This statement is true. Yes, it is not a part of integers. Negative square root of 4, that will be negative 2. Negative 2 is a part of integers. Yes, this is true. Square root of 3 is a part of rational numbers. So this statement is false. 7 divided by 9 is a part of Rational numbers. Yes, rational numbers can be written in the form p by q. So this statement is true. 0.201 is a part of integers. This statement is false because 0.201 is not a part of integers. 7 divided by 0.31 is a part of rational numbers. So 7 divided by 0.31 can be written in the form 700 divided by 31. And we know this is p integer, this is q also an integer. Therefore, we can say that this number is a part of rational set. So this is true. Now square root of mod of -1. Mod of -1 will be +1. So square root of +1, that will be 1. 1 is a part of real numbers. So this is true. Let's move on to the next question. Determine whether each statement is true or false. Now z plus is a set of positive integers. Now set of positive integers is a subset of natural numbers. So we know set of positive integers starts from 1, like 1 2 3 4, and set of natural numbers is 0 1 2 3 4. So this statement is true. Now set of natural numbers is a proper subset of part B. Set of natural numbers is 0 1 2 3 and so on, and set of integers is 0 positive -1 positive -2 positive -3 and so on. Now is n proper subset of Z? Yes, we can say it is a proper subset of Z. So this statement is true. Now part C says n is equal to Z plus. Now we know Z plus is 1 2 3 4 and so on, and n is 0 1 2 3 4 and so on. Now the question is asking n is equal to Z plus, so this statement is false. Question D says Z negative is a subset of Z. So Z negative will be -1, -2, -3 and so on. So is this a subset of this one? Yes, this is true. Now Q is a proper subset of Z. Now we know Q is in the form P by Q, or 1.23 or 1.234 bar. The question is asking Q is a proper subset of Z. Z is a set of integers. However, Q is a set of rational numbers. So this statement is false. Part F says 0 is a subset of Z. Now Z contains zeros, so this statement is true. Z is a subset of Q. Z here is a subset of Q. No, this is not true, so this statement is false. Now Z plus union Z minus is equal to Z. Now we know Z plus is this, Z minus is this. And if we take union of both of these, is it equal to Z? No, we still have one term left, that is 0. This element 0 will still not be present. So this statement is false. Let's move on to the next question. Describe the following sets as either finite or infinite. The set of integers between 10 and 20. So there will be a finite number of integers between 10 and 20. So this is finite. The set of integers greater than 5. So there are infinite number of integers greater than 5. So this will be an infinite set. The set of all rational numbers between 0 and 1. So their rational numbers are p divided by q, where p and q both are integers. So we can take any values of p and q as long as p is less than q. So p is less than q. Given this condition, we can take any values of p and q, and hence there will be infinite number of solutions. So this will give infinite number of elements in this set. Let's move on to the next question. The question says, if universal set is a set of integers, so Z is a set of integers, and this is universal set. Find the complement of Z plus. We also know Z plus is a set of positive 1, positive 2, positive 3, and so on. So the complement of Z plus prime is gonna be 0, comma, all the negative integers. So this is our answer. That's it for this exercise. I'll see you in the next session.